Okay, here we are with video number 5. Let's see, where do we want to go next? Maybe I'll jump to the first page and then we'll come back and hit that last one in a second. So let's start with problem 7. This says solve for x, show your work. Hint, you don't need to complete the square to solve these problems. I threw that in there because when my honor students did this review, a lot of them were attempting complete the square, probably because that's what we just learned in this unit. But we also learned about complex solutions, right? When there's an imaginary number that's part of it. So we wanted to do this type of problem. The reason we don't need to complete the square here is we don't have a linear term. We have a quadratic term and 2 constants. Notice that there's not an x to the first power or just x anywhere in this. We have x squared, no x's at all. So because of that, we want to get this equation to a place where it looks like x squared equals number. Then we can take the square root of both sides and we're done. So we don't need to complete the square here. All right, I'm going to start by subtracting 26 from both sides. 2 minus 26 is negative 24. To get x squared alone, I'm going to divide both sides by 3. 3 divided by 3 is 1, so I'm left with x squared equals negative 8. Now that I have something squared equals number, this is where I can take the square root of both sides. On the left, I'll have x. On the right, I'll have positive and negative. The square root of 8 is 2 root 2. Because it was negative 8, it's 2i root 2. Just a quick reminder of why we're doing the plus and minus. Okay, so let's take a look at this. If we knew, again, this is just a made-up problem, so this isn't one of the problems on there. I'm just throwing in another something for us to think about. If we know that x squared equals 9, we can probably just guess that x needs to be 3, because 3 times 3 equals 9. But there's a second answer here as well. If x were equal to negative 3, then we would take negative 3 times negative 3, and that would be 9. So we need both answers when we solve this. So what we usually do is take the square root of both sides, we get x alone, and then we just remember that we want the positive and negative root when we're solving these, because we want to find all the possible solutions. Okay, let's move on to the next one. Again, isolate x squared. So we're going to start by subtracting 27 from both sides. We'll get 4x squared equals, I think that's going to be negative 36. Some people, when they get to a spot where they see a perfect square, like 36, you want to jump to square root right here. Please don't until we get x squared alone. Okay, so divide both sides by 4 first. We'll get x squared equals negative 9. Now, if we take the square root of both sides, we'll have a more accurate answer. Plus or minus. Yeah, usually people make a mistake at just that spot. Sorry. Okay. The square root of 9 is 3. The square root of negative 9 is 3i. That I shows up because of the negative that was under the radical there. Sweet. Let's try 9. Okay, we want to isolate x squared, so we're going to add 1 to both sides. Now we have x squared over 4 equals 6. X squared is being divided by 4 right here. In order to get rid of the 4, we want to do the inverse operation. If we had had 4x squared equals 6, where 4 is being multiplied to x squared, we would have divided in that case. In this case, to get rid of the 4, we're going to multiply. If we multiply this side by 4 and we multiply this side by 4, notice that 4x squared divided by 4, that's just going to be x squared. That's supposed to be a 1, but it's sort of sideways. So 1x squared equals 24. And then we can take the square root of both sides. We will get x equals plus or minus, let's see, 64, that's going to be 2 root 6. I think, let me just verify. Yep, plus or minus 2 root 6. And if you're ever feeling unsure, feel free or take the opportunity to plug in your equation, right? So if I were doing that here, I have 2 answers that I want to check. I want to check 2 root 6 squared. Your calculator should be able to handle this with you. I'll divide it by 4 minus 1. If if I plug that whole thing in, which might take me just a second, arrow out squared, turn that whole thing into a fraction, over 4 minus 1, we should get 5, and I did. And if I put a negative right here, it's going to be the same thing, right? Because I'm squaring, so that thing's going to go away. So we can always check our answer. It's a good idea, especially in a test where it's sort of high stakes to get the right answer the first time. Okay, isolate x squared. So we'll subtract 5 from both sides. I get 13x squared equals 39. Divide both sides by 13. We'll have x squared equals, I think that's 3. Yep, so square root both sides, and we have x equals plus or minus the square root of 3. Let's check 11. Add 20 to both sides. 7x squared equals 63. Divide both sides by 7. We get x squared equals 9. This is the one we talked about earlier when I said I was making up a problem, huh? But now we know that the solutions are positive 3 and negative 3. Okay, on 12. This one looks kind of interesting. So we're going to start by adding 1 to both sides. Then we've got negative 5/9 x squared equals 25. What we have here is a fraction, negative 5/9, being multiplied to x squared. So if I treat this carefully in my calculator, I can divide both sides by negative 5/9. Your calculators are quite good at fractions, so you'll probably be in good shape. When I taught at the other school with calculators not so great as fractions, we would do 25 divided by, then I'd have them do parentheses, negative 5 divided by 9 parentheses. That way that would work out. But I think what we're going to get here is negative 45. So we'll take the square root of both sides. X equals plus or minus. Because of that negative, we're going to have an I. Let's see, 9 times 5. I think we'll get 3i root 5. Let me check this stuff. Negative 45. Square root 45. 3 root 5. Yeah, we're in good shape. Okay. All right, let's look at the top of this page. This part should seem easy compared to what we've been doing now, right? Simplify the following radicals, show your work. Show your work if there's work to be shown, I guess. So the square root of 64, that's 8. The square root of negative 1, that's I. So what we have here, we can just go straight to that, 8i. Okay. Square root of 242, if I put the negative into my calculator, it doesn't know what to do with it. So if I don't put it in, I'll see that I get 11 root 2, but because of that negative that I want outside the radical, I'm just going to put an I there. Some people are concerned about the placement of the I, and it's not critical. Typically, we put it after the coefficient, which is the number out in front of the radical. If there wasn't a number there, I would just put it right in front of the radical. In this case, there was no radical, so it went behind the number. But if you had I times 8, that's still correct. It's just not how it's conventionally written, so you're still good. Okay, I'm going to look for the square root of 196. That's 14. Because there's a negative under there, our answer is going to be 14i.